At the Horsepower Factory, we're certainly known for our modifications and upgrades to Holdens, Fords and Subarus. But recently I was approached by a customer with a European car, and it excited me because it takes me back to my past when I was an apprentice working on Porsches and Rolls-Royce. But this car wasn't a Porsche or a Rolls-Royce, it's something a little bit different. And the expectations of this customer are certainly high, and certainly it's been a massive challenge to deliver what the customer wanted. So I'm going to take you through this car and explain to you a little bit about what we've done and what we're going to get out of it.
England, known for Big Ben, the Queen and dental hygiene. But most importantly, the Aston Martin.
Okay, so it's a 2006 Aston Martin Vantage, standard running a 4.3 litre V8, 6-speed manual transmission. The car had already come into us set up for doing Targa Tasmania, and it has actually competed in quite a few events already. It had a CAMS approved roll cage, 2 Cobra race seats, some 6-point harnesses, has great brakes on it already. Really, the chassis, everything, the handling is all fantastic. The only thing the customer really wanted was a little bit more throttle response. He wanted more control over the engine management in terms of traction control, had issues with fitting different exhaust on it and then bringing on check engine lights, that sort of thing, causing the car to shut down. It had been to a number of other workshops and they had really struggled to try and resolve those issues. Basically, he wanted a little bit more performance out of the car, and we said the best way to start is with Motec. Mark.
Hey Rob, how you going?
How you going, mate?
Good.
Mate, just thought I'd drop in. We've got a 2006 Aston Martin Vantage at work.
Yep.
That we wanted to fit an M800 on, and just wasn't sure about the fly-by-wire and variable cam timing.
Okay, well generally fly-by-wire and variable cam timing's not really too much of an issue. The V8 one, isn't it?
It is a V8, yeah.
Oh, okay, yeah.
Have you done one before? Or?
I think we've pretty much done like the V8 Vantage. I'd have to check the exact details.
Yep.
With the fly-by-wire, we do it based on like the serial number.
Yep.
So sometimes you can get different throttle bodies, but I mean this car's got fly-by-wire on it as well. We generally just calibrate them all to suit. So if we've done that serial number, then I've got all the information. If not, send it in, we'll sort it all out. That's no problem at all.
Okay, and the cam timing?
Cam timing generally, that'll be basically the same. Like if I know what's on the engine, if it's the same as the one we've already done, not a problem at all. If not, simply have a look at the car, tune it to suit, job done.
Have you got an example of the fly-by-wire? Can I have a look?
Yeah, I've got one. I'm just tuning one now. You can have a bit of a look at it.
Check it out.
Yeah. Here's a throttle body I've already been tuning. This is off a new Holden V6. So effectively what I've done, this is just exactly what you'd find in your pedal. It's 2 throttle position sensors.
Yep.
Feed that information into the M800. The M800 deciphers that, sends a signal to the throttle body to make it work. So effectively, I move the throttle position sensors here and the butterfly moves.
Okay.
The ECU is controlling the motor just through a couple of outputs. No cables needed.
Yeah, gee, okay, so that's going to work well. I suppose this car's being used for Targa, so things like traction control, can we tie that in with the throttle?
Yep, absolutely. What I would suggest doing is you can basically map the throttle for the driver's feel, because even when they're doing traction control, they'll still want to move their foot around. It's just natural for a driver. Yep. But what we'd end up having is you'd have a map in there for where the throttle needs to be based on the driver's foot.
Yep.
And then when the ECU detects that there's wheel spin, basically the back wheels are going too fast, the ECU will automatically start closing that throttle body to get rid of your wheel spin.
Okay, so that's really the ultimate solution for a tarmac rally sort of car where the conditions are changing constantly.
The really good thing about the drive-by-wire traction control is some of the reports from the driver, it feels more like what they would be doing with their foot.
Yep.
More probably as opposed to like the fairly abrupt cut when you cut the engine.
Yep.
So this is probably a nicer way of doing it.
So the fly-by-wire throttle, cam control, they're extras when I order the M800. I need to get those functions enabled.
Effectively, it's like ordering a car. If you don't want the leather seats in the V8, you don't pay for it. Of course, if you want the leather seats in the V8, we'll do it. So you don't get stung if you don't need to use
if you don't need to, fair enough.
So it's a bit of a modular kind of system.
Excellent. And the cam control, have you got something you can show me how that works?
Luckily enough, I've got an engine on the dyno that we just happen to be tuning.
Well prepared today, I'll tell you.
Absolutely.
Let's have a look at that.
Cool. Okay, Rob, what we've got here is just a nice simple Subaru variable cam engine. So effectively these cams can continuously change phase when compared to the crankshaft. A bit like the old days when the guys used to get their Chevs and advance or retard the cam depending on what they were doing on the track. But these days we can have them move wherever we want, whenever we want. So just as a bit of an example, if I bring this engine up just about 3,500 revs, see the torque come up, I'll just wait for that to level off. So we've got like 77 horsepower there. Now if I move this cam around to get it more in a position where the engine's going to work better, there we go, we suddenly pick up torque and horsepower simply by moving the cam. Now in this engine I simply can go through and tune and put the cam exactly where I want it, when I want it, for the maximum horsepower all the time. And that basically broadens the spread of torque by moving, always having the cam in the position that we want.
Yeah, which obviously in a tarmac car or a race car, when you're coming out of a corner, you want maximum torque to pull you out of that corner.
Oh, mate, if you've got this nice expensive engine and it's got all the technology, you might as well use it because it does make a huge difference.
Yeah. And I suppose that's the great thing about Motec, really, isn't it? I mean, you've just got so much flexibility in the things that we can control, and you know, we've talked about traction control, we've obviously shown me cam control here, fly-by-wire, but that is the beauty of Motec, isn't it? Just that flexibility. Well,
it's whenever someone rings up and say, okay, what does this ECU do? It's really a completely open-ended question. All of the maps and 3-dimensional maps, 2-dimensional maps, even 4-dimensional maps, I can use over 400 different channels for each axis. So I can tune boost control on heart rate if you really want to.
Really?
Absolutely.
Unbelievable.
Yeah.
Yeah, I suppose that's the reason, you know, when these customers come to me, I thought of Motec straight away because, you know, $200 and something thousand car, obviously sophisticated in its, you know, engineering. We certainly want to try and match that up with an engine management system that's going to be able to control all these things. We don't want to lose our cam control. You know, we want to retain our fly-by-wire. And that's been one of the reasons, I suppose, or the problems that we've had with the car, making modifications to the car with the factory ECU has caused us to go into limp mode and have problems with, you know, trying to control things. Obviously, Motec's going to just eliminate that and give us 100% control. And the Motec software, the i2 software, I'm not an expert on it, but from what I've looked at, you know, it's got some fantastic features that you know, you can literally hook it in so that you can monitor what you're doing every corner on a circuit. You can, you know,
Yep.
have G sensors. You can have, you know, literally the video of the track, the corners and what you're doing hooked up with the data, so you can, you know, tie it all in. I mean, it's
Absolutely. I mean, in a similar way that the ECU, the idea behind the ECU is you want to know exactly what you can do at all times and change it around. With the i2 software for the data logging, okay, we can get all this U-view data, but the idea is with the i2 is I might look at data different to the way you do. So the options are there. Again, that Motec flexibility. You just have to be able to look at things nice and quickly and the way you want to see them. So you don't want to spend all your time at the track just sifting through this data. You want to have a quick look, job done.
I mean, where does it all end? Is there any end? Obviously, you can hook it up to your heartbeat. What else can we hook it up to?
Well, the jokes have always been to use our ECUs and our dashes to control other things like houseboats, the coffee machine upstairs.
Yeah, okay.
There's a lot of different applications that it's all, like I said, it's an open-ended question. What do you want it to do?
Yeah, fantastic. All right, well, I better get back to work and get this Aston Martin underway.
Not a problem.
Thanks, mate.
Catch you later.
When computers were cool and cars came out of the factory with carburetors, this man, Richard Bendell, founded Motec, setting the benchmark for the world's best engine management systems.
My name is Richard Bendell. I founded Motec in '87. I've been a long-term motorsport enthusiast since I was 18, which happens to be about 50 years ago now. And during that time, fuel injection was looking like it was going to be a good thing, but the manufacturer systems were so difficult for people to use. There had to be a better way to do it. I dreamt up an analogue system that was operated by a screwdriver over given rev ranges, but I couldn't put it into action because I've got very little electronic knowledge. So it was a case of finding a suitable consultant that I could work with. After a year, we actually developed it and it worked, and we ran it at Bathurst, and we had a lot of sales over a few years as a result of that. The system, which is this what we call the screwdriver box, as I say, it'll have an adjustment range, and it would tell you when you're on that particular adjustment range, and you purely turned it left or right to make more or less fuel. It was a good system, it was simple, it was reliable, and it held us in good stead for probably 3 years and helped establish us in England in particular, and in America slightly later. But as cars got more complex, people wanted a better answer to a difficult situation. The technology went by the board and we went to full digital systems. Now the first of the digital systems was what we called an M8. It ran everywhere from Le Mans to Nürburgring to the various American circuits, not to mention virtually all the V8 supercars in this country. Again, its life was tapering off when they started to bring drive-by-wire engines in, variable camshafts, variable lift valves. So consequently, the M800 series, which does everything that this does in about half the package, plus a whole lot more, including onboard diagnostics, scope patterns, to help people that basically were starting to get to the end of their knowledge and needed a bit of help to understand not only what they're doing, but why they were doing it. So that again held us in good stead, and now the fourth iteration is the new M series, which is a magnesium cased, ultra lightweight, very sophisticated device. But the secret of Motec over its history has been making difficult projects easy. This will have a multitude of derivatives for diesels, direct injection. It can be used for gearbox controllers. So it has a multitude of uses, but that's why we've gone from 1 engineer to 16 engineers. The company's gone from, as I say, 1 person to 35 here, 12 in England, about 15 in America, and we've recently started a division in China. That's been in operation 2 years now. Most of the devices that we've developed, going from the screwdriver box, the M8, the M800s, have typically a life cycle of about 5 or 6 years. And it's the old story, it's better obsolete your own product than have your opposition do it for you. And that's why we have such a drive on latest levels of technology. But the secret has been using the high levels of technology, but making it usable to the customer. That in the end, it's no good having a rocket scientist who's the only person that understands what he's doing if the customer can't use it. And that's where most of the skills go, is making a very technical, difficult project into a simple task.
When I was approached about doing the car, it seemed pretty clear to me straight away that we needed to fit an M800 and take control of the engine management completely. And that's what we've done. We've fitted an M800 on it. We've basically taken control of everything, throttle. We've actually fitted a Motec traction control unit on it that gives the driver, I think, 8 positions. It is absolutely a fantastic car to drive now. It was before, but now it's just got that little bit more throttle response. We did a couple other little tricks. We did check the exhaust standard, and we did find there was a couple of little restrictions which we've modified the exhaust to remove those. We also did some testing on the air intakes. We thought maybe the factory air intake and airbox setup was a bit restrictive, and like most cars these days, late model cars, one of the first mods you do is fit a K&N filter or change the airbox to a different style. But what we found was the factory air intake system was very good, and we didn't really need to do much with it. So after doing that testing, we decided to pretty much leave it alone and concentrate on other areas of the car. You know, it only takes me a second to say we fitted M800, but I can assure you the job itself was far, far harder than that. A car like this is very technical. It is all integrated, everything's relying on everything, and basically we needed to keep the dash functions as much as we could for the customer. He wanted to retain all those. And so we had to actually run the factory computer integrated with the M800, and that basically to get those to work in harmony together and for the car to operate correctly was a fair old challenge, and we'll go through some of those issues that we faced.
So basically what we decided to do was, here's a picture here of my beautiful drawing of the standard ECU, and some of the inputs that are going into the ECU, which we've got here is the airflow meters, MAFs, crank angle sensor, the cam angle sensor, engine temp, air temp. And then from that, the ECU then has its outputs. So it'll drive the drive-by-wire, it'll drive the injectors, the coils, fuel pump, fans, dash. That's just some of the things that it does. What we basically worked out is that we needed to still run the dash, the fans, I was even going to try and leave the fuel pump working. And just take control of what the minimum we have to take control of to actually be able to control the engine to its optimum, but not upset anything else. So what we did was I shared all these, okay? So I didn't actually have to modify any of them. I could just take that into there, that into there, that into there, and that into there. And then it gets the inputs enough for it to be able to run. Then what we did with that is we took control of these ones here. So I took out the drive-by-wire, injectors, the coils, and run them into the Motec. Okay, so effectively now the Motec is controlling the engine things that it needs to control, but the standard ECU is still getting its inputs that it wants to see and is still happily running the dash, the tacho, the speedo and all that sort of thing. The first problem I had once I got the engine up and running was the fuel pump wouldn't run. As soon as it saw that I'd taken away the drive-by-wire, it said, I've got a major error here, turn the engine off, shut the fuel pump down. So I had to then go into trying to control the fuel pump. Now, for us, when we looked at it, looked in depth into it, it was much easier for us to fit a different fuel filter in the tank that actually has a fuel pressure regulator built into it. So what that enabled us to do is just run the fuel pump flat out the whole time, and the fuel filter with the regulator in it would control the fuel pressure and give us a constant fuel pressure of 4 bar, which is exactly what we wanted to run. Okay, so what we've had to do is the fuel pump is now being controlled by the Motec. The next problem we got then was, so got fuel pressure, everything going, attempt to start the car, and it's sort of firing but not quite firing. And then what I worked out was I had a weak spark. Now what we have here, having this workshop manual here, is I'll just draw a picture of an ignition coil in the case here, and what it has is it has a battery 12 volts, it has its own ground, and then it has a signal that was going to the standard ECU. What that normally means is that there's got a module built into the coil because it's got its own 12 volts, it's got its own good ground, so then basically all the current is normally being controlled within the coil. But in this case, once I took control of the coil and put it into the Motec, it was overloading the Motec, and the Motec couldn't handle the current that the coil was trying to draw. So what I had to do was fit modules between the Motec and the coils. Once I did that, then I had a good, healthy, strong spark, and the car started and run, and that's where I am now. The car's up and running. I've conquered all of the problems that I've come across so far, and I'm about to start wiring up the traction control.
Overall, the car is now finished. We've prepared it. He's about to go and do an event down in Tasmania, and the car's been completely gone over, prepared, and before it goes, I'm going to take it for a bit of a drive and just make sure I'm happy with it. But I'm really looking forward to seeing what the finished product's like now with all the changes that we've made, because I did drive it before, and I'll be interested to see what the HPF team have been able to do to this car. The first thing you notice when you hop in this car is just how snug the cabin is. I mean, it really is set up for racing, and if you're a bit weight challenged like myself, it's certainly not so squeezy as they say, but it feels very direct. I mean, everything feels very tight and direct. The steering, the suspension, and this is all standard. This hasn't been modified. It's not like it's got a set of aftermarket shocks and springs in it. It's actually the way it comes from the factory. It does have a set of race tyres on it, which you definitely can feel. You can definitely feel the difference of those, just the different style of tread. It sounds sweet. It does sound like a real V8. Might just give it a little thump just to make sure she's all good. Pretty noisy in the cabin. I'm pretty sure a standard one wouldn't sound like that. We have, as I said, made some exhaust modifications, and it definitely has opened it up, and it actually sounds pretty sweet once you start getting on up in the RPM. And certainly, I suppose, when you've got a helmet on, it's nice to be able to hear the engine. Sometimes if a car's too quiet with your helmet on, you can't hear what the engine's doing. You can see it visually, but you can't always hear it. But this car definitely, even with your helmet on, you'll know exactly how hard you're going with the engine. I just can't get over how the chassis gives you so much feedback. Just a small little rotation of the wheel, you can absolutely feel the directness in the steering. I haven't had the pleasure of driving one of these around a track, but I'd certainly love to find time. Maybe might have to talk him into give me a drive when he's out of call the next time.